What is meant by ion? لما أقول أنا ion, it's an atom ولكن with a charge. So it's an atom or a group of combined atoms that has a charge. يعني باختصار هي atom or molecule بشرط عندهم charge. وهيدا charge may be positive or negative. فإذا الأيونز are of two types, cations and anions. الكاتايونز ions with positive charge, بينما الانيونز هن ions with negative charge. الكاتايونز may be monoatomic or polyatomic. monoatomic هي وحدة بتكون such as Na+, K+, Mg2+, and others. بينما البولياتوميك NH4+, H3O+, and others. لما نقول anions ممكن كمان يكونوا monoatomic and polyatomic. المونواتوميك such as Cl-, O2-, Br-. بينما البولياتوميك NO3-, SO4-, CO3-, and others. Note: when the atom loses electrons, it converts into ion, which is cation. For example, Mg2+, Na+. فإذا لما الأتوم تخسر إلكترون or electrons تتحول لكاتايون. الكاتايون عندها positive charge. بينما when the atom gains electrons becomes ion واللي هي حقيقة anion such as Cl- O2-.
There is a nucleus in the center and a cloud of electrons swarming around it. And the electron cloud itself is divided into electron shells. The outermost electrons, the valence electrons, are the reason why chemical reactions occur at all. Smaller atoms with only one electron shell can hold a maximum of 2 electrons. In the larger atoms, the valence shell can hold a maximum of 8 electrons, no matter how large the atoms get. There is something special with having exactly 8 valence electrons. It gives the atom a kind of stability. Here is a chlorine atom. It starts out with 7 electrons in its outer shell. If it could only get one more, it would reach that magical number of stability. It wants an extra electron so much that it can pull it away from almost any other substance. That is why chlorine is so reactive. The chlorine atom is neutral to start with. It has the same amount of positive protons and negative electrons. When it gets that extra electron, it becomes a negative ion with a charge of -1. We write it as Cl-. As an ion, it's not reactive at all. Now that it has 8 electrons in its outer shell, it doesn't need to steal any more electrons. Some atoms change their name slightly when forming ions. The ion of chlorine is called a chloride ion. Here's another atom, oxygen. It starts out with 6 electrons in its outer shell, so it wants to get 2 more to reach that magic number of 8. When it picks up 2 electrons, it gets a charge of -2. The ion is called an oxide ion. We write it like this, O2-. So, when an atom has an almost full outer shell, it wants to take up more electrons. But what about atoms that start out with just a few electrons in their outer shell? Let's look at aluminium. It has 3 electrons in its outer shell. You'd think that getting 5 more would do the trick, but there are limits to how many extra electrons atoms can get. What the aluminium atom can do instead is get rid of its valence electrons. This is how all the metals form ions. Does that mean that it now has 0 electrons in its outer shell? No, look, as the electrons from the third shell go away, the second shell becomes the outer shell, and that had 8 electrons to start with. When an atom loses electrons, as metal atoms do, it becomes a positively charged ion. The aluminium atom loses 3 electrons, so its charge becomes +3. We write it like this, Al3+. Atoms that form positive ions don't change their names, so this is simply called an aluminium ion.
Chemical symbol of some ions. وهول بنصح طلابنا الكرام انه يحفظون، مع انه في بعض المدارس واذا بدنا نحكي الشيء المضبوط بالدولي لغوا حفظهم وانما بيكونوا given، بس مش خطأ نحفظهم، بنكون ماكنين اكثر بمادة الكيمستري. بتذكر بصف الثامن كنا نسميهم للطلاب يعني chemical language، لغة الكيمياء. طبعا بنشوف استاذنا شو بده، اذا بده ايانا نحفظهم بليز اعطونا اهمية، او ممكن نحن نستعين فيهم كجيفن بالسؤال. فاذا an ion is represented by the symbol of an element followed by the charge. يعني for example بنقول O2 minus، ما بنقول O minus 2، وإنما O the symbol of the element followed by the number then the charge O2 minus, Na1 plus or Na plus, Al3 plus, SO4 2 minus and so on. How to write the formula unit of ionic compounds by using طبعا the criss-cross method. If we take for example calcium chloride، calcium إما حافظينها أو بتكون given Ca2 plus، chloride Cl minus. So by using criss-cross method عملية عكسية، بنلاحظ الرقم اللي هون بينزل لهون absolutely يعني بينزل 1 مش minus 1، والرقم اللي هون بينزل without sign يعني 2، so it's CaCl2. Ca1 بس ما بنحط ال1، Cl بتنزل لهون فبتصفي Cl2. magnesium phosphate، the magnesium is Mg2 plus، الفوسفيت PO4 3 minus. criss-cross method حيطلع في عندي اكيد Mg، قلنا بتنزل ال 3 اللي هون، ولكن ال 2 حتنزل وعندي انا P and O، so PO4 between brackets 2. Okay, this is the formula unit of magnesium phosphate.
For example, we know that sodium loses one electron to form a sodium ion. We also know that the electron is not lost, but transferred to a chlorine atom to form a chloride ion. Let's grab a piece of paper and a pencil and work on this example. Write down the ions side by side along with their charges. Remember that the charges are written in superscript. Now, circle the charges and crisscross them, just like how it's done here. We will bring the charges down so that they are in subscript. 1 is never written in a formula. It's assumed that no number written means that there is one atom. So the resulting formula is NaCl. The positive metal ion always comes first in both the formula and the name. For the negative nonmetal ions, the first syllable stays the same, but the ending is dropped and replaced with an "ide." Chlorine becomes chloride. So this ionic compound is called sodium chloride. Let's keep that piece of paper because we will do another example, this time with magnesium and oxygen. Let's write the ions along with their charges side by side. Then we will crisscross these charges. We should get the following formula, Mg2O2. However, 2 to 2 can be reduced to 1 to 1. Therefore, the formula is MgO. The name of this compound is magnesium oxide. Remember that we keep the first syllable and we change the ending to an "ide." Find the formula and the name of the ionic compound formed from calcium and fluorine. Please pause the lesson and resume once you are done to check the answer. The formula is CaF2, with the 2 written in subscript, and the name is calcium fluoride. If we were to think about it, everything we've described makes perfect sense. We know that ionic compounds have an overall neutral charge, so all charges present must be fully balanced. Using your calcium fluoride example, we can see that to fully balance these charges, the calcium 2+ ion must form an ionic bond with 2 fluoride ions. This concept is stitched together when writing its formula, CaF2. We will do one more example together, this time with aluminum and sulfur. The formula is Al2S3 and the name is aluminum sulfide. Polyatomic ions. These polyatomic ions are ions made of more than one atom. Remember that mono means one and poly means many. Some common polyatomic ions include hydroxide, sulfate, nitrate, phosphate, carbonate, and ammonium. Note that with the exception of the ammonium ion, all of the listed polyatomic ions are anions. You will have to remember the formula and the charges of these polyatomic ions. Let's grab a piece of paper and a pencil and work on the first example. Write the sodium ion and nitrate ion side by side. Remember to include their charges. Let's crisscross these charges. Since we never put 1 in a formula, the formula for the ionic compound in question is NaNO3. When naming ionic compounds made from polyatomic ions, we just write their names as they are. The name, therefore, is sodium nitrate. Now, for our second example, let's write a magnesium ion and a hydroxide ion side by side. Let's crisscross these charges. The structure of the hydroxide ion is not changed when forming an ionic compound. For this example, we simply need 2 hydroxide ions to fully balance out the +2 charge of the magnesium ion. This is represented by placing the O and H in round brackets and the 2 as a subscript. So the formula is MgOH in brackets 2, and its name is magnesium hydroxide. Let's say we did not put the OH in brackets. We would get MgOH2. This would mean that for each magnesium ion, there is 1 oxygen atom and 2 hydrogen atoms, which is incorrect.